I think that measurement is a concept that needs to be really emphasized during the elementary years. I think this is something that we could teach very well so students mastered it and would be able to carry it with them into high school and into life. We need to make sure we're teaching measurement at a very beginning level with elementary students. They need to understand what the whole idea of measurement is, why we do it, what's the purpose. We need to talk to them about standard and non-standard measures, and we need to start with those non-standard measures so that they can think from the very beginning about how this mathematical concept developed. Once we've done much practice with measurement, with actual objects, non-standard measures, standard measures, then we get to things that are used on a regular basis. We want to make sure we're teaching students both metric systems and the American standard systems. In some ways, teaching metrics is easier because we have that 10 factor. In another way, it isn't easier because students in their own life may not see it as often. So we need to make sure that we are teaching well the kinds of measurements that students will use, whether that be the metric system or other systems. For example, I know a lot of high school students and even adults who struggle to read a ruler to the nearest 16th of an inch. It's just very difficult for them. How would you teach that to students? Pause the video and think about how you might draw and explain the fractional parts of an inch to students so that they don't end up being one of those teenagers or adults who can't read a ruler. Then see if your ideas agree with mine. So I have just created here a very large inch. If we've taught fractions well to students, we can use that knowledge to model what we want them to understand about reading that ruler. If I put a line halfway, then I have a half of an inch. Most students will understand that. Then I might say to my students, I want you now to divide that whole inch into 4 equal parts. You have it in 2 equal parts right now. How would you make that 4? So students might say, well, I could put a line here. I've already got this line. I could put a line here. Now I have 4 equal parts. So what do I have? I have 1/4 of an inch, 2/4 of an inch, 3/4 of an inch, and 4/4 of an inch. And then I might say to my students, what if you divide your inch into 8 equal parts? What would that look like? And students hopefully would be thinking, well, I have 4 right now, so I'd have to divide each one of them in half. So now I have 8 equal parts. What does that look like? Well, I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. And then I might say to my students, okay, one more time. What if you divided your whole inch into 16 equal parts? What would that look like? And hopefully students would say, well, I have 8 parts now, so if I divide each of those in half, I should have 16. And they might want to count just to check. So what do I have now? If I go through my whole inch, I have 16 parts. And if I label them all, I will end up with something that looks like this. Now this work is really good reinforcement for fraction understanding as well. Students can look at this and they can see things that are equivalent fractions, things that are the same. Look at all the different names we have for 1/2 of an inch. We have 1/2, 2/4, 4/8, 8/16. So they can understand that even though there's only one line here, and on a ruler that might be the biggest line between 0 inches and 1 or 1 inch and 2, and it's a big line because it represents 1/2, the bigger parts. But it also represents 2/4, 4/8, and 8/16. So we need to remember that as we're working with an inch. So if I'm measuring something and it ends up exactly here, I can say it's 1/2 of an inch. If I measure something and it ends up exactly here, I can say it's 5/8 of an inch because I know that halfway line there is going to be 4/8 and this is going to be 5/8. So teaching students to look at these lines, what does that big line mean? What do these lines mean that divide into 4 equal parts? Where are the lines that divide into 8 equal parts? Those tiniest lines are the sixteenths. So if I'm measuring something and it goes to one of those tiny lines, I know right off the bat that I'm going to be measuring in sixteenths. And I need to count every line, the small ones and the bigger ones, because even though those lines are bigger, they are still counting the sixteenths of an inch. I can look at those equivalent fractions and I can say, well, yes, this is a bigger line, which means it's an eighth, but it's also representing 2/16. So if this were my measurement line, I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 sixteenths. When we're teaching measurement, we need to make sure that we're teaching all the different kinds of measurement, and that includes time. Working with time, we want students to have clocks in front of them. We want to talk about time, the movement of time. But what about when we get to the point where we're actually calculating time? As you think about students explaining to you what they understand about adding, subtracting, multiplying, or dividing time, what kinds of concepts would you have to teach them? What kind of thinking would you want to hear from them? Pause the video and see what you think. We need to remember that time is a non-standard unit. Our hours, minutes, and seconds are not on base 10. So for example, let's just imagine that we're talking about students practicing a musical instrument. And one week, they practice 3 hours and 15 minutes, and the next week, they practice 2 hours and 45 minutes. How much have they practiced? Well, if we add this together with our usual adding, we can add and get 5 and 5 is 10. This would be 60 minutes. This would be 5 hours. But now we know that 60 minutes makes another hour, so our answer is 6 hours. That conversion is something that we need to make sure we teach intentionally. What about if we have to practice 6 hours and 15 minutes for the week, and we have practiced already 2 hours and 30 minutes, and we want to know how much time we have yet to practice? Well, a lot of students will do this. They'll take one of those hours and they'll put it over here like this, as if it were a 10 or a 100 base system. But it isn't. That hour that I've taken here is 60 minutes. So I need to be thinking 60 minutes plus the 15 minutes I already have is 75 minutes. And if I take away 30 minutes from that, I have 3 hours and 45 minutes. So pointing out these non-standard measures and making sure students know how to convert them is important. What if I'm going to practice 45 minutes a day for 3 days? How many minutes will that be? Well, 45 times 3, 135 minutes. And I could leave it like that. But if I wanted that in hours, what would I do? There are 60 minutes in an hour, so I would have to divide this by 60 to figure out how many hours that was. And I would have 2 hours and 15 minutes if I converted that. What if I wanted to practice 6 hours for the week, and I'm going to practice 5 days a week? So I divide 6 hours by 5 days. How would that look? Well, I can divide that just the way I would here, and I can say, well, that would mean 1 1/5 hours. What if I want to know how many minutes that is? Then I'd have to convert my hours to minutes. There are 60 minutes in an hour. 6 hours would be 360 minutes divided by my 5 days. Then I would end up saying I would have to practice 72 minutes a day. So that means that 72 minutes is the same as 1 1/5 hours. Helping students with that non-standard conversion, something that's not based in base 10, is very important. What do you think is important when it comes to teaching students to measure in length? Inches, feet, yards, miles, and the metric system. Pause the video and see what you think. It's very interesting to point out to students how the two different systems we use to measure length compare. For example, we have 12 inches in a foot. We have 3 feet in a yard, which is 36 inches, 3 feet in a yard. We have 5,280 feet in a mile. We have 1,760 yards in a mile. When students look at these numbers, they're often quite confused. Where do those numbers come from? So going into the history of how these measures came to be can be very interesting for students. But ultimately, they do need to memorize them. The relationship isn't obvious. Compare that to the metric system, where we have in the metric system 1 meter, 10 meters, 100 meters, 1,000 meters. Everything goes by tens. Or if we're getting smaller, we can have a centimeter or a millimeter if we're taking 1 and dividing it into smaller parts. 1,000 meters is a kilometer or a kilometer. So students can see that in the metric system, conversions are so much easier because they're all based on 10, just like our base 10 number system. At some point, we also want to teach students a little bit about one system converting to another. Now, at the elementary level, I'm not sure I'd get into this too much, but I think it's important for them to know about what a centimeter looks like. We can show them about what is a centimeter and how does that compare to an inch, just so they see the differences. A millimeter is very small. I think we also want them to understand just very generally the relationship between a kilometer or a kilometer and a mile. We can teach them that 1 kilometer is equal to 62 hundredths of a mile, or a little bit over half a mile. So a kilometer is much bigger than a mile. Those general comparisons are important for students to know, I believe, at the elementary level. What would you want students to understand about cups, pints, quarts, and gallons and the relationship among those? Pause the video and see what you think. These measures are another example of a measure that is standard because we use it, because everyone knows what a cup is, a pint is, a gallon is, but the relationship among them is not really predictable. One way that I like to teach this is by having students create a person. This is going to be the body of our person. This is going to be the head of our person. Our person is going to have 2 arms and 2 legs. On each one of our arms and legs, we're going to have a 2-part hand and foot. And in each one of our 2 parts on our hands and feet, we're going to have 2 small pieces. So this is our person. And I allow my students to make the face on the person and add hair and name the person whatever they want. But what we have here is a gallon person. This is a gallon. Each one of the arms and legs is a quart. Each one of those small pieces that represent the hands and the feet is a pint. And each one of those smallest pieces is a cup. Now, what I like about this is that students can connect and relate one to the other. For example, there are 2 cups in a pint. They can see that. 2 cups in a pint. There are 2 pints in a quart. Here are my 2 pints connected to the quart. There are 4 quarts in the gallon. 4 quarts connected to the gallon. Or if I say to my students, how many cups are in the gallon? They can look at the connections. They see 4 here, 4 here, 4 here, and 4 here. So there are 16 cups in a gallon. They can compare this in a lot of different ways. The measures are not logical. It's not like the metric system where there are 10 in the next and 10 in the next. So students really have to memorize them. So in some ways, having a visual for them to help can make sense. Measurement is an important part of life every day. Whether those measurements are metric or non-metric, whether it's weight, whether it's pints, cups, quarts, gallons, whether it's length, whether it's temperature, whether it's time, we need students to have a lot of practice in this so that they understand that measuring is a way to communicate things they see in the world. If they say something is 20 miles long, I can picture that, I can see that. That's why we have systems of measurement.